All right. All right. So quiz tomorrow. First half calculator. So obviously 5-1. Some of it requires a calculator. Other parts do not. Like if I ask you to find the area using Riemann sums, midpoints are pretty rough without a calculator. Right ones, left ones, it depends on the function. The example in your review would also had a table of values, which threw some of you off a little bit. That one, you really don't need a calculator for, okay? And if you can do 3 or 4 rectangles, I don't need you to show me you can do 20 on a table. So it's not going to be just busy work, all right? It's going to be, can you do this? Show me your work. Do you need b minus a over n if it's a table? What's b minus a over n used for? To find the base. B minus a over n tells you the width of every base, right? If they're all the same. Do you need that if it's a table of values? No, you get to look. Oh, look. This one goes from 1 to 5. Its base is 4. This one goes from 5 to 6. Its base is 1. You don't need b minus a over n unless you are told like 10 rectangles of equal width from like from the interval from 1 to 9. How wide is each one? Make sense? So part of 5-1 might require a calculator, other parts may not. The definite integral, being able to convert from a Riemann sum notation into definite integral notation. There was one, I'll be honest, we ran out of time and things got really like broken up with the snow days. And so that was the next level of the converting from Riemann sum notation into definite integral notation. We did not do. We're going to do it as we review for the AP test. But you saw the one in the review that was optional. That was like a next level conversion process that is not going to be on the quiz. Normally it would be. All right. No calculator part. We learned. Let's keep going. Talked about converting, properties of definite integrals, additivity, reversing the bounds, makes an opposite area, sum, difference, constant multiple, all those. You also need to know, we talked about which properties do not work for definite integrals, right? Is 3f of x dx from a to b the same as 3 times the integral? Let me say it again. 3f of x dx inside the integrand. 3f of x. Is that the same as 3 out front times the integral of f of x dx? Yes, that was a property. Integral of kf of x is k times integral of f of x. Okay, so you may get like a matching or a multiple choice that says which of these are or which of these are not, and then actually gives some numerical values and solve them using those properties. What else? Average value of a function. I know your calculator can, if you type that in, I know your calculator will spit that out as an answer. So obviously it's going to be on the no calculator part. You need to show the antiderivative, show the average value part. Okay. So if you liked the way I've been doing it, you need to have some sort of logical notation that gets you there. I think I broke it. There we go. Again, you need to have some sort of logical notation that gets you there. For example, if it's like 1/5 from 1 to 7 of x cubed minus 2x plus 1 dx. And this is your setup, and you got to solve it. Okay? You may choose to call this little f of x. And then I would need to see, in the directions, I will say, I need to see your antiderivative function. That is a checkpoint along the way. So maybe you write out the antiderivative, and then you show me what capital F of 7 is, capital F of 1, show the subtraction, and don't forget to put a fifth out front. Now, this is the symbolic notation, capital F. You're actually going to plug those in. Right? You're going to get numerical values. You're going to plug them in. You're going to show me that work as well. I'm just showing you the symbolic steps I would need to see. Does that make sense? What to see along the way? All right. I kind of skipped over this part. Finding areas with antiderivatives. That is what we do most of the time, right? Here, find the integral from 2 to 5 of this function. And you calculate the antiderivative, you plug them in, subtract, area, done. Average value I told you about. Derivatives of an integral with a variable upper bound. That's the d dx out front. D dx out front. It's got a variable upper bound, maybe it's x. And then you do the Tyler, right? It's just that with x's in it. That's the rundown of what topics are on there. All right. How did the actual calculations go and the solving of these problems? Do you need me to run through a RAM problem? I think it's probably helpful. Believe it or not, that gets missed. You're gonna have to, and by the way, you're gonna have to sketch. So on the calculator part, whatever region you're drawing rectangles in, or actually calculating rectangles in, you're gonna have to do a quick sketch with those rectangles drawn in. So if you've been kind of shortcutting those homework questions that ask you to calculate that and haven't been drawing them out, you might want to practice that. Believe it or not, that the drawing of the rectangles. You got replaced. You're out. You can send it out. Down to it now.
Kicked out of the
Smarter over here.
You said Madison seat.
Yeah.
What's wrong with my old seat? Awkward. I don't know. Once you move to that seat, like your insight just went up quite a few levels.
It's just gotta pay attention more.
That's true. All right. So, am I going to need a delta x equals b minus a over n in this one? You guys did this last night, right?
Yeah.
All right. What's delta x? B minus a over n, 6. 4/6, 2/3. The base of every rectangle is 2/3. Meaning, my first rectangle stretches from -3 to -2 1/3. Yes? I don't know where that is. And I'm not using the height at -3. I'm not using the height at -2 1/3. I'm using the height at the midpoint of that. Connect it over, connect it down. That is the first rectangle. Okay. Now, that's not, I'm just sketching it to show you what it would look like. I don't actually know where 2 1/3 is on this graph, just to be honest. Okay. I'm just sketching a sample rectangle to show you that. Make sense? All right. Now, the area, the MRAM6 area is going to be 2/3. I factor it out. It's 2/3 times the first height plus 2/3 times the second height plus 2/3. The 2/3 is in every calculation. You can factor it out and then start to do the calculations based on the midpoints, based on the first midpoint, second midpoint, and so forth. You should have 6 calculations. Now this is where we go to the calculator. X cubed plus 2x squared plus 4x cubed. Was it plus 4? X cubed plus 2x squared plus 4. Okay. Control T. There's the table. That's not the table I want. I want to menu, table, edit table settings. Where do I want the table to start? I'm going to give you some choices. Okay. Is my first value at -3? No. You may choose to work around this. Listen carefully. This is hard to explain. Here's -3. You could choose to have it give you the value at -3, then the value at the midpoint, then the value at the next right end point, the next midpoint, and you're gonna have to pick out the ones you want. Do you agree? Let me give you a piece of advice. If you can find the x value that gives you the first calculation, the x value that will give you the first height calculation, then all you need to change your steps by is 2/3, because you're going to hop from midpoint to midpoint to midpoint. You get what I'm saying? So if you put in the work to find the x value where the first midpoint is, or what if it was an LRAM? Well, that's easy. Your first x value is going to be at the first left edge. RRAM, the x value that's at the first right edge, -2 1/3, and then hop by 2/3 every time. Are you with me? So what is the first x value that I want? It's not -3. It's not -2 1/3. Say it again. -2 2/3. Do we agree? How are we going to put that in the calculator? It'll recognize improper fractions. So what is that as an improper fraction? -8/3. Okay. I think, let me double check, just to make sure. -8/3. And we're going to step by, what did we decide? 2/3, because that's our delta x. So if I go from left end point to left end point, it's 2/3. Midpoint to midpoint, 2/3. Right end point to right end point, 2/3. Whatever one you're asked to do, it's gonna, our delta x is 2/3. So every hop is 2/3. Now let's make sure the first calculation. All right. Do you see it down here? That's unfortunate. Okay. Here's what I would do personally. Okay, you're gonna have to round to the nearest 1,000. Okay. 2 options. How many? Are you guys doing this along with me in the calculator? Oh, you got this? That, If it happens tomorrow, if you want to plug it in to your laptop and people turn the laptops around and kind of close them to keep them charged as you go, that's fine. All right. There's a question. What did you do? That's fine. So did you do the menu trace, graph trace, and type it in? That's fine. So that's the second thing I'm going to give you as an option. Okay. Option 1, I'm going to write down negative 0.74. I would go 0.7, just round to 3 at the very end. And then 4, and then don't do that to me. And then 5.1852. And make sure you have 6 of these. Make sure when you're done, you have 6 calculations that you're adding up. Are you with me? So, to Wendy's point, if you're over, now, you know your navigational pad? If you scroll over here, did you see how I clicked over here? I can click in the table. I can click over here. There's 2 different windows open right now. If I'm over here, I could do menu, trace, graph trace, and I can physically type in every x value that I want calculated. So wasn't my first one negative 8/3? And then enter. And it should give you negative 0.7407. And then you'd have to go to the next one. And that's why it's kind of nice, because if you have both of these working together, you can use your table to tell you what the next x value is to type in if you're concerned this is not giving you the correct values. No, I think there's ways around this. I think we can take this if you want to get more decimals. Why is it doing that? What's happening? All right, another piece of advice, and these are all optional. If you want to bring your TI-84, look at your Expire, type in the calculations on your TI-84 and add them up in your TI-84. That's fine. That's probably a good idea. Okay. Questions on that problem? I know I'm spending a lot of time, but this one always gets tripped up.
How do you pull up where you can make this step?
So once you're in the table, hit the menu button, and then table, edit table settings. Now, some people want to get rid of the table. You have to have that border highlighted, and then hit Control T to get rid of the table. Okay. Questions on that problem? All right. Was this one all right, Wendy? On this problem, I want to see the calculations. I want to see that every one of them has a base of 2/3, and then I want to see either symbolically 2/3 times f of negative 8/3. Like I actually want you to put in negative 8/3 here and then negative whatever it is here, or write out the decimal of the height at that point. It's like negative 0.7408 or 7. Either one. All right. Everybody understand that? What's expected? That's AP across the board, by the way, in math. You have to show your setup work. If you're using a calculator, setup work, and then what goes into the calculator, and then the final answer. All right, table. 3 rectangles. Doesn't my first rectangle stretch from 1 to 3? Base of 2. Height of 5. Ready? Here's your interval. 1, 3. Use the height at 1. Left edge. 5. Plus, okay, what's the next rectangle? What's its base? 2. What's the left edge here? 1. Plus, next one. From 5 to 7, what's the base? Coincidence? Left edge. Add them up. What's that, 38? 38? What would the units, let's say the T is in, this. I did not write this on your problem, but let's say it's in meters per second. If I ask you for the answer with units and context, you would say 38 meters, and you would describe that as the displacement of the person, bike, object, I don't know, from 1 to 7 seconds. All right, this one, our bounds are -5 to 7. Our C sub k's were like the midpoint or the left edge point endpoint, but they're not just every so often anymore. There's infinitely many of them. So they become 3, they become x's. So that is writing the integral. I did not ask you to evaluate it. Come back to that one later. Average value. Do we need to see this one? What'd you get for the answer? 7? 7? So what do I need to see here? I need to see 1/3 times the integral from 1 to 4 of 4x minus 3 dx. Did you guys use antiderivatives here? It could have been geometric. It's a line. You could have made rectangles and triangles, but practice antiderivatives. So what would I need to see here? Your first checkpoint. What's the antiderivative of 4x minus 3? Don't forget your plus c. And then I would need to see the calculation at 4, the calculation at 1, the subtraction with the 1/3 out front, and then your final answer. Okay? Tyler, what'd you get here?
Drawing an X.
Here you go. Ready? Now what? Now you'd have to take the antiderivative, plug in x, plug in -7, and subtract, and that would be, what kind of answer would that be? A function of x, and it would mean input x, output area. Good. It's not what it asked.
Do we, for the d over dx, do we have to show what the antiderivative is, or do
No.
you just want to just?
I don't know what that antiderivative is. And that's kind of the hook on the question. It's like, oh no, what am I supposed to do? Deep breath. It's okay. I don't need to find it. Okay. Back to column 1 with x's. That one wasn't. Was that one on yours? What'd you get? 16, 12 minus 2. Is it 14?
Yeah.
Questions on that one? Will you ask me if you do? Question? Question? Jackson? Question? Got it? All right, 7 was a little rough. 7 would not be fair game for the quiz tomorrow. But just out of curiosity, did you recognize the antiderivative of one of x? ln absolute value x plus c. We've discussed it. I haven't explained why. I think I might have explained why. It's been a long time. I actually graphed. We did a problem. Let's see. This is the challenge of teaching. Most people need to hear things more than once, which it's my job. I'll explain things over and over, right? However, we talked about how the calculator gave us an error sometimes, right? We'd take a derivative of something and it would say, careful, the domain of the derivative is greater than the domain of the whatever. We talked about that. What's going on there? And the idea here is, do you agree if they give us 1 over x and we find the antiderivative? Let me say it again. They give us 1 over x and we find the antiderivative. Didn't that antiderivative need to be smooth and continuous? To have that as its derivative? Let me say it again. Didn't the antiderivative need to be smooth and continuous to have that as its derivative? That's why there's a problem. ln, what's ln of regular x? Not absolute value. What's ln of x's domain? When is it continuous? Greater than 0. So what should its derivative domain be? Greater than 0. Wait a minute. 1 over x. It's all real except for 0. That's a problem. Okay, let's make ln absolute value of x so that it can take in negative inputs and match what its derivative should be. Kind of tricky, isn't it? We'll talk about that later. Not for tomorrow. Make sure you're good with trig. How'd you do on 14? What if I put a problem like 14? Tyler?
Yeah, B minus A.
Don't just put an x in there. I was trying to trick him. He's unflappable. He's unable to be flapped. Huh? Now's not the time. Actually, that's fine. Probably is the time. Who's calling me now? Snow day. Sign us home early. Do you agree you would need the antiderivative? Plug in x, plug in 0, subtract. Is your answer going to be a number, an area? No, it's going to be a function of x. You plug in an x, get out an area, right? So be careful there. But if I do this, I'll just sign it back. Man, you guys are not even going to need to learn 5-4. You're going to be like, I've over-explained the fundamental thing with calculus. Like, you guys are going to be good on 5-4. Easy. You guys are doing really well on this stuff. You're doing good. When you focus. Are there any of these you'd like to see worked out? Any of these ones you'd like to see worked out? These ones are easy to check in the calculator. Are there any other questions on the review you'd like to discuss? We'll take the first half right now. Speaking of starting early, who's starting right now? You girls?
It's like just plug in X.
All right, we'll do it out in the hallway. Calculator part? Is your calculator ready to go? You see the new one I'm testing? The blue trim around the edge.
Whoa! You wouldn't give us that with that, okay. But when it uses DVX, that's
Yeah, it's called. I thought you were saying yes. You were saying like a reflective background. Why did you rainbow? No.